Welcome to my project whatsapp.com. Title is Incremental Affinity Propagations Clustering Based on Message Passing. Go to abstract. Affinity propagations is a new algorithm that takes as input measures of similarity between pair of two data points and consider all data points as potential assemblers. Real valued messages are enhanced between data points until a high quality set of assemblers and corresponding clusters gradually emerges. We have used affinity propagations to solve a variety of clustering problems, and we found that it uniformly found clusters with much lower error than those found by other methods, and it did so in less than 100 the amount of time because of its simplicity, general applicability and performance. And then the proportions of IAPKM is inspired by combining k-metods and affinity propagations clustering, where affinity propagations clustering is good at finding an initial assemblers set and k-metods is good at modifying the current clustering results according to new arriving objects. Affinity propagations algorithm can be used in this paper finding the similarity word sequence. Two IAP clustering algorithms, one is IAPKM and IAPNA, are proposed. Datasets and real-world time series are used to evaluate the performance of IAPKM and IAPNA. Experimental results validate the effectiveness of IAPKM and IAPNA. The flow is user side collect the clustering dataset, in server side loading the clustered data, and pre-processing the raw data, and filtering the data, and clustering extractions. Clustering extractions from the clusters using the affinity propagations method. We clustered the objects, then message passing from user to the server by using clustering algorithm. And K-mean clustering algorithm used in these projects. K-mean is one of the simplest unsupervised learning algorithm. Procedures follow a simple and easy way to classify a given dataset through a concerned number of clusters fixed a priori. The next step is to take each point belonging to a given dataset and associate it to the nearest centroid. When no point is bending, the first step is completed and a yearly groupage is done. At this point, we need to recalculate k new centroids as center of the clustering results from the previous step. After we have this k-mean centroid, a new binding has to be done between the same data set points and the nearest new centroids, and retrieve the old and new objects. Finding accuracy and time computationals and memory utilizations is calculated. Let us see the demo. Go to next and browse the dataset. The dataset name is PIMA dataset, is also a clustering dataset. Open this dataset. It's also a numerical dataset. Accuracy is here more direct measures to reflect the effectiveness of clustering. Go to next and view dataset. Data are loaded into database and view this data. Nine fields are listed and pre-processing the data. Symbols are converted into null. Pre-processing successful, and null values has been deleted. And original data set is symbols. Some symbols is here, and after pre-processing show this original data and go to next. So also here data extractions of process, and enter the bandwidth, give 10 to 100, I will 34 and one way to do is 54, number of users 95, calculate the timeout window and create the 5 users, and dataset length is and data extractions of 16, dataset size is 3072, and go to extractions. Now I move to 200. Okay, extraction size is 200 KB. Data extracted, data extractions of particular user, and previous I create the 5 users and extractions of number of users 0 to 5, and go to next, and file selector, select the dataset, and open this dataset. File has been uploaded, and file splitting, the input file size is 24,047. Enter the byte size to extractions the file into some values. I give 3 and okay, and select the directory. This dataset files are split into 3 bytes. Check these files. These files are extracted. File has been extracted. Go to next. The static dataset is, it's also an existing process, and go to next. Split based on clustering, K-mean clustering algorithm, clusters which is separated by reducers or 3 parts, and go to next. It is also a dynamic, this is proposed process, and enter the number of clusters. I give 6 and view clusters. The numeric datasets are clustering and split based on clusterings on 6 parts 0 to 5, and enter the number of data. Go to submit, and number of value inserted, I give 1 time insert those values. Okay, enter this 9 dataset fields. This data is also stored in a clustering dataset. Enter the all details and insert successful. Go to view clusters. These details are split into age calculations using K-mean clustering algorithms, and cluster 0, cluster 1, and so also split it into 0 to 5 parts, totally 6, and add dynamic data is also added, and go to next. Finally, finding the computational time, accuracy, and memory utilizations. Go to computational time. X-axis is proposed system and the existing system. Y-axis is time computationals. In existing system value is only 15, and proposed system time computationals is 80. And existing system values and proposed system values. And accuracy is it's conflict between clustering and accuracy. And finally, memory utilizations. Only full utilizations of the proposed systems. Thank you.